Hi there, my name's Darren and welcome to this session on total R values. Now this can be a session related to anywhere that is using our total R values for walls, for floors, for roof systems. I'm going to go ahead and use this project here and add some designs for total R values. Now you may have a blank project and you may just be doing total R value calculations, or you may be integrating your total R value calculations for your walls, roofs and floors directly into a model, which you can certainly do. Now when we go ahead and create them, we're just going to go to the project space and then we're going to create a new design. You see I've got a couple of designs here. I've already created these. I'm going to go ahead and create a new one. And we'll just call this example R value calc. Okay, done. So we've created an example R value calc as a title. We've added it as title. Now we're going to just select wall system because that's the R value calculation that we're going to be undertaking, one for a wall system. Now if you've got to this stage and you're not seeing these brands, then you might be in New Zealand. Or you may be overseas and you are going to see applicable brands for your market. And generally speaking, we're probably this interface here may change a small bit because we are finding more and more folks like to create their systems from scratch. So that's what I'm going to do first. I'm going to create a wall system from scratch. And this is how you do it. You don't select any of these logos here or the typical templates. You go to empty template. And this is really for the adventurous, but for what a lot of people want to do. Once you go ahead and go to an empty template, you get the opportunity to start building it out. So the first step is to add a material layer. Now if we left click here, you'll see a bunch of categories pertaining to material layers. We're going to add on something that represents an external material. And I'm going to just select the generic material, aluminium sheeting. There it is. That is a sheet of aluminium. And it happens to have a conductivity of X, 210, thickness, density, and a name. Should you want to change the name, you can go ahead and change that if it's a generic product. If it's not a generic product, you can't change the name because it's a product from a supplier. Now that's been added, we can then go ahead and click this Add Material Layer Plus button here and add on a second material layer. I'm going to add in a bridged air cavity. I'm going to keep with the generics throughout this example, and let's say that has a steel top hat within it. There you go. It's a bridged air cavity with a steel top hat. You can go into this, update whether it's ventilated or not. I'm going to say it's slightly ventilated. Your exposure generally is going to be to the outside. And if you want to edit the framing, you can edit the framing in terms of its conductivity, frame thickness, vertical spacing, projection, and frame height. Next, we're going to add on a secondary water control layer, otherwise known as a membrane. So let's go ahead and hit the plus button again, and we're going to navigate to membrane. I'm going to select a generic product and let's call it a class 4 vapor permeable membrane as per the 4200.1 standard. So there you go. That's specific to Australia, but as long as it's a vapor open product, vapor permeable product, then that's good enough for this demonstration. Next, we're going to add an insulation layer behind this. So our thermal layer, we can add it either here or we can add it here as a bridged air cavity and then fill it. So let's add it here first, and then we're going to select generic products, and I'm going to select a glass wool product here, and there it is, insulation. Of course there's something missing, and that something that's missing is the stud framing that would always be there to support it and to support the rest of the building. So should you want to change things, you can change things, but let's go ahead and add on framing. Select Add Framing, navigate to Generic again, and I'm just going to simply put in a timber stud. Left click, there's the timber stud. It's now there in the system, and once you go back to edit framing, you can go ahead and edit the distribution of that framing, its conductivity. Use your arrows on your keyboard to go back and forward, the number of noggings, etc., sometimes called dwangs, and you're going to change the overall framing percentage. So if we go ahead and nominate this out, we might find that that gets it extremely large, in some cases up to 30% for a typical wall, even above. I'm going to click save here, and now we've got that framing included within our system. Next up, we're going to then select a finish for the inside, an internal material, again on the generic side, and let's call it plasterboard. So there it is. A wall system has now been built out from the external to the internal side, and you can go ahead and nominate that thermal value or thermal selection here, and click run one simulation. Now, depending on really where you are, it will calculate a slightly different R value. In Australia, there's going to be a 4859.2 421 calculation. In New Zealand, 421 it can be 4212, and if you are overseas, it might be a 6946 calculation. So it will be stated anyway within the actual calculation summary. But because this project is in Brisbane in Australia, and it is in climate zone 2, then effectively what we can see here is that there is actually a target value there of 1.4 pertaining to the minimum requirements of the National Construction Code. And then the green is giving us the big tick that, hey, you've met the minimum requirement, because of course the bigger the number, the better the thermal performance from a thermal resistance perspective when it comes to total R values. So over here on the left hand side, you can see a breakdown of the results, and we see a simple breakdown in terms of the material layers and their resultant R values, and where a material layer is combined with other material layers, we get a total. Down the bottom here, we see the temperature correction results based on the 4859.2 requirements, and this is the item that's missing from the facade calculator. Now, if we close that out now, let's adjust this system, and we're going to put on a different framing. We're going to not go there, we're going to go here, select timber stud, and adopt a steel frame. As many of you will know, steel framing has a very high, or performs very poorly from a thermal perspective, unless it has been significantly improved on the exterior side. So we will see a resultant change in the thermal performance down to a value of 1.13, and it's now not meeting the minimum performance requirements of the code. So just as I add on steel, I will make a point that there are very specific requirements from a thermal resistance perspective that come through the 4214 calculation methodology, and contact resistance is one of them. It's a let's say it's a dubious assumption that you're going to get additional thermal resistance on your frame, but if you want to meet the precise requirements of 4214, then you can select that to be on. If you do select it to be on, you will get a different result there, but just bear in mind that that is probably not a reflection of reality. It's a reflection of some simplicity in the calculation method. Now that's there, we can go ahead and go back to templates and look at some of these other scenarios. So we've built out an empty template, but we may also want to select a template. And this is simply selecting a template that's already been built for you. So very, very little work to do. And the big benefit here is that you can go ahead and take layers out, tweak this template, and save it as your very own template. That is the big benefit. When it comes to other templates that are not better building templates, they are from suppliers. Let's go ahead and look at, let's say, Kingspan, and select one of their products there. You may find that there's a bit of a lock-in effect when it comes to specific products that have been provided by the supplier in reference to their template. So you may find yourself with limited options to change things. May do. It's not always going to be the case, because suppliers, if they have tested a wall system and they have provided us with that testing data for a specific wall system, then they may want to present the wall system without the ability to change things, because that is the specific system that has been tested. But once you're happy with a supplier's template, you can go ahead and lock that in, should you wish. And then if you want to get into some really complex stuff, you can also do that with some systems. So I'm going to pay reference to DC Tech here, who have been on the platform a long time, and we're going to look at something that is not a typical system, but a system that requires a calculation methodology that cannot be undertaken through a standard 4859.2, 4214 in Australia, or a 4214 in New Zealand, because effectively the calculation methods are based on residential wall systems. This is a very commercial wall system where we have insulation placed on the outside, and we have a specific framing system, in this case something called NV1, and it's part of the envelope system range. The reason I'm identifying this is that in these systems you can edit the framing pertaining to this system in a multitude of ways, including setting the horizontal spacing, the projections, and the vertical spacing. And you may want to consult the supplier once you're doing this, because they will point you in the right direction about what is the most suitable settings for a particular system, subject to wind loading, location, etc. But the point here is that if you run this calculation now, you are going to get an ISO 6946 calculation, where an upper limit and a lower limit is determined in order to calculate the total R value. This is not a direct reference in the National Construction Code, nor is it a direct reference in New Zealand, but New Zealand is going this route moving forward, and you'd hope that Australia would follow suit as well, because it's a more flexible approach. Like all standards, it's certainly not perfect, but it does allow you to go ahead and complete a system that is more complex than what the residential base systems within New Zealand and Australia would typically allow. Now, I'm just going to go ahead and pull this system up as a last example here, and I'm going to then navigate over to downloads here. And should you want to download this, produce a report on this, provide this to someone in your design team, you can go ahead and do that, no problem at all. You will get the opportunity to identify a theme being a way to replace our branding with your branding. So if you have that, you can go ahead and identify that, and you can create that, see the other on-demand course for that. You can also add additional information into the model too. And as usual, I always recommend that you consider providing this information in. It's only a small additional step, but what it does, particularly when it comes to councils, or when it comes to someone wanting to review the nature of the report that you're producing on the platform, you will be able to include lots of additional information that should help the readership of that report. Once you download, you can simply download it, it will drop onto your desktop, and it will be a report that is relatively detailed. I'm going to go ahead and grab this report here without any themes or including any project information, just to give you an idea of what it looks like. And here is that report. So there you go. We have some branding that you can replace. You can replace the colors, the fonts, the table display, but effectively we have results, and these are provided for you with a target if there is one and whether it has failed or not, all assumptions pertaining to the modeling itself, a little render showing the wall system in question, all materials included within the system, and the detailed results right there at the end. So lots of detail for just a wall system, but you can certainly go this route should you want to provide this to any other party for review. Now, if that's not your bag, you can also just take a screenshot of the actual calculation results here, because we know a lot of people do this. Or you could go into the results here and potentially go ahead and grab the results by copying them over and dropping them into an email or a consultant's advice note or other. So there you go, a nice quick run through total R values for the platform. Just as I was about to log off there, I've just realized that there's a couple of other items there that I really should talk to when it comes to nuances around the system. So this module section here, which may move in the future, has a total height. This is just the total height of the wall in question, and that will change the percentage of framing within the system, because as soon as you change the height, you're going to change that percentage framing. The contact resistance we've talked to a little bit already, so we're going to leave that on there if we want to be purists around the 4214 calculation methodology. For cavity bridging, whether framing selected in a cavity has an impact on the cavity thermal resistance. So a real nuance there, but if you have an unventilated cavity, for example, and the thermal resistance of that unventilated cavity becomes quite high, then do you account for thermal bridging within it? Completely up to yourself. And then cavity bounded bridging, where the thermal bridging layers add the resistance of air cavity, which is disabled, or treat them as discrete layers when using NZS 4214. What that means is that in some systems, such as, let's correct this system here. I say correct it, let's just change it. And I'm going to change that to, just for exaggeration, I'm going to change that to 100 mil, noting that 100 mil systems don't exist. But what this is saying here is that the thermal bridging layers add the resistance of air cavities, and that's been disabled. And what happens technically is that you can get, because of nuances in the codes pertaining to this calculation, i.e. NZS 4214, the air cavity itself can have a theoretically higher R value than the insulation, which is nonsense, and it will lead people down the path of reducing insulation to replace the replace that insulation, for example, reducing 90 mil to 75 mil with an air cavity, just because the calculation methodology determines that that air cavity is extremely high. So that doesn't make sense. And it leads to questionable outcomes. So please bear that in mind should you want to consider it. Okay, there you go, that's it. I'm going to leave you there. Waffled on for long enough. Feel free to go ahead, take that quiz. It's only 10 questions, and get the 80%, and we'll issue that certificate of completion for you to use as you would like. I'll leave it there. Thanks a million. Bye-bye.